This is Amar Mujahid, and you are watching the first lecture on tutorial series of group theory. In this lecture, I will tell you about the definition of group and some basic examples of group. This is the definition of group, and it is actually the next stage of a set. A group is a set G together with an operation satisfying the following four axioms. The first one is a closure axiom. The second one is associative axiom. The third one is identity axiom. The last and the fourth one is inverse axiom. These are very basic axioms, and I hope I don't need to explain these. Now, let's see the definition of finite and infinite group, also an abelian group. If the number of elements in a group is infinite, then it is called the infinite group, otherwise finite. Now, here it is abelian group. A group G is abelian if x operation y is equal to y operation x, for all x and y belongs to the group. Now, this is the basic example of a group. Actually, this is a set of all positive and negative integers, and we have to check that either this is a group or not. Here binary operation is addition. It is obvious that for all x and y belongs to G, x plus y is also in G. So, closure axiom is satisfied. Now, associativity. This implication is obvious in integers. Now, the identity is 0 in this group, because when we add any integer in 0, it does not change. Similarly, the inverse of any element is same. But with negative sign, all four axiom is satisfied. So, this is a group. Also, this is an infinite abelian group. Now, there is another example of set of 2 cross 2 matrices. This is a set of 4 elements. We use Cayley table here to check that this is a group or not. Closure axiom is obvious. We can see that from Cayley table. Every element has itself its inverse. This group is called the Klein 4 group. We later use this group. This is example number 3. And this is an interesting example of a group. In this example, we have to check that all possible symmetries of an equilateral triangle makes a group or not. Take first triangle as identity, and call it I, and name their edges 1, 2 and 3. Now, rotate this 120 degree and call it A. Again rotate it 120 degree and call it B. Now, pick up all 3 triangles from upper edge, and reflect these, and call these C, D and E. So, we get 3 more triangles. In fact, these are the 6 possible symmetries of an equilateral. Now, we have a set of 6 triangles. Again, we use Cayley table. We define an operation on these symmetries by saying that the symmetry x operation y should be obtained by first performing y and then applying x to the result. You can see here Cayley table. It checks each of the group axiom except associativity. After computing this Cayley table, we are able to say that this is a group. Also, this is a non-abelian group. This is the end of a lecture. Thank you for watching this video.